my talk will be about the UnionToIntersection utility type. So what is it? Why would you use it? And how it's working? Yeah, I think it's especially interesting because it uses quite a couple of interesting TypeScript features. Probably many of them you might know, but it's still interesting to analyze how does it work. All right, so so what? Let's just go straight to the point. So this is the UnionToIntersection type, and yeah, it looks quite intimidating in the beginning when you look at it. So we have some generic type which takes generic T, and we can see that it uses it uses couple. So it uses sorry. So this is the conditional types. It uses Infer. We'll see that it uses also the covariant and contra-variant feature. So bear with me, and we'll see how it really works. But let's first just take a look. What does it really do? So if you use it with some type argument, like in the first example, like string number, so it does what it really says. So it takes the union of types, and as a product, it tries to create it creates intersection of those types. So in the first case, we have intersection of string and number, which is never, and which is not very interesting and useful. But in the second example, we can see that we have some object types or interfaces. We can see that might be more useful. If we intersect them, we get the resulting object type, which has both properties from both of these object types. So this looks a little bit more useful already. So as you can see, here's one example, one use case. So generally, you could have a union of object types, like here, let's say, which don't have common properties. So here, let's say imagine there's some users which they always have which they can have like a different properties with social links, like Twitter URL, LinkedIn URL, GitHub URL, and we would like to have the keys, let's say all the possible properties which in this object types can appear. And yeah, how would you do it? Without this utility type, it would be difficult, because of course the key of user doesn't work because there are no common the properties are not common, so we wouldn't get this as a result keys. So how does it work? So I'll briefly describe a couple of the things which are used here in this utility type, and then how it works. So we're using some specific features related to naked types. We use generics, we use conditional types, we use the infer keyword, which is part of conditional types, and covariant and contra-variant. Yeah. So first, maybe let's look at conditional types. So so this is something you probably know, introduced in TypeScript 2.8. So basically, they allow us to compare like input type T in this example, some generic, to some other type using the extend keyword. So if it extends this particular type, we can choose some other type as a result of that. So So here you can see some simple, useful conditional types like a string or non-nullable, which choose type based on the on this matching, which comes after the extent. A second thing I wanted to mention is naked types. So basically types are types which are not wrapped in another generic. So they're not in an array, tuple, promise, or in function. So this, and we will look at them like in the context of conditional types. So here we see that this conditional type T here is naked. So it's not wrapped in this position in any other generic, yeah. But here, this other generic type not naked, you can see that the T here is wrapped. It's in generic, basically. It's an array generic. So this would be like a non-naked use of type here. So the feature which is used in the UnionToIntersection type is that the conditional types when they're used when they're naked in their usage, they're distributed over union. So let's see. So this is the same type defined here, this naked T, and if we pass union as an argument, and this usage here it's naked. As a result, we get just the union of this generics. So this is distributed over this generic. And if in the case of not naked, this doesn't happen. So this usage still is not going to be distributed in the same way. Yeah, so this is it. Next thing is covariance and contra-variants. So basically, this is the feature which also was changed in one of the versions of TypeScript. So basically, the strict function types flag changed the way how function arguments and types of function are matched against. So before it was less strict. Now, to be more strict and more sound in the type system, the functions arguments of function are compared to each other when deciding whether this particular function type is a subtype and can be used in another place in a covariant, a contravariant way. So basically, in our context, that means that if we have two functions like f and g, which have here the same argument, like the same argument name, but they're different types, and if we want to create a union of these functions and see what type of this function has, then we'll see that to be sound with using this strict functions type, and which is under the strict feature flag. The arguments and the resulting fg function need to be intersected. So in that case, for example, the resulting type will be never, since string and number intersected against each other give the never type. So this just doesn't exist. It's also like behaves differently. So this in the case of the, let's say the same example, but the arguments here are object types. So here, if we define the same fg function, which is also like a union of those two functions, the arguments here will be intersected between each other, and will give us an object type which with both with properties from both of these arguments. So, and yeah, the last thing related to that is the infer keyword, which is strictly related to conditional types. So So basically, it allows us to allows us the type to for us to infer, so get the type based on the in the conditional type. So for example, we can get we can pass here in the case of return type, we can get the if the type is really a function, so so it has arguments, any arguments, and returns something, and we can infer this something, this infer, and return it, and return something else if it's not a function. And in that here, and it's another example where we have infer argument from this looks more complicated, from the object which has two functions, a and b, and we want to look at the shared argument. So in that case, we're also looking at this in the contra-variant way. We're trying to infer intersection of those arguments. So for example, in that case, it would be string, because string and string is string, but in the other case, we will get never. All right, so let's get with this tools. We can get back now to the original UnionToIntersection and take a look how it really works. So let's look at the example, simple example. So so we have as an argument, we have union of these two simple object types with Twitter, one with Twitter URL, with the second one of GitHub URL. And we want to, get the, resulting object type with both of these properties. So the first thing, as I mentioned, so we're using this type T in like a naked way. So this usage is distributed over union. So getting using this and giving an argument this union of the types, we get just the union of two separate UnionToIntersection with those arguments and with those separate arguments. So as the next steps, let's look at the substitutions. So as you can see here, so basically, in the first step, we look at this T, which extends any. So this is basically always true. So as a first step, we choose this the first part of the conditional type. So this function from x of type T to any. And this is basically this first step. So basically we have this x of type T, and in our case, this is type T, this first object type to any. And and of course, this is the second part of the union. So this is with the GitHub URL, which any. So we have this first substitution done in that place. So let's look at the second part. So second part also, if you look at it, so extends, we also match against the first part of this conditional type. So it matches against this. So we get as a result, we're gonna infer this argument for both of these functions, which they're arguments of the same type. So here in the end, like we get x, and we want to infer from function from x to any with infer r, and this is really, like in the first case, this is this Twitter URL object with Twitter URL, and the second part would be is x with and we want to infer the type r with which is really this GitHub URL object with GitHub URL. And so, yeah, we're getting close to the end. The last thing is that, as we mentioned, the contra-variant. So we know that when we have two functions and we have union of them, their arguments are going to be a contra-variant. They're going to be contra-variant. So basically, they need to be intersected. Both object types need to be intersected, and as a result, we're going to have the intersection of these two objects and one object with object type with these two properties. So using this trick with wrapping this type first in the function and then inferring its type and unwrapping basically, and then inferring the type of the unwrap function, but also putting that into two separate functions, which arguments need to be contra-variant, we get this final result of intersected arguments of this whole UnionToIntersection function. Yeah, the generic function. So yeah, that's it. Yeah. Thank you. Yeah, thanks.
Okay, awesome. Thank you. Okay, does anyone have any questions? I guess if you have questions, then you can just unmute yourself. And Kuba will be happy to answer.
It was, so clear that.
Yeah, it was such a good explanation that no questions.
Yeah.